Hello, check, check. One, two, three. Alright. At first, I would like to welcome all of you to my pre-presentation of the PMS PPJO Solar Turbine. Alright, so good evening, good night, and good day all to you. Before we continue, we start with the introduction. Okay, so here this is the single line diagram, the simplified one. So we have 5 GTG. So this one, if you could see my cursor, there is a we call bus bar A. Alright, so it consists of 4 generator and divided by a tie breaker, and then go through to the bus bar B. Then this bus bar B supplied by one generator. Alright, so here is the picture of the HMI. Okay, so okay, we proceed. Okay, what is our objective? So basically is to test out the modified logic. So to check the new logic is really follow the Excel. So here is the Excel. So actually we have a ton of the sequence and logic. So just to simplify, okay, let's say we take one example, scenario 2. So let's say all of the 5 generator run. So this the first one CB6 will be shine first, followed by the number 2 and so on. Alright, so then how is the testing setup? So here is our logic. So this logic have been downloaded into a emulator. So how about its IO? So it will be simulated by this HMI. Alright, so then how is there any for this one, is there any logic need to modify so this HMI could follow the setup? So here I create one simulation routine. So let's say if generator 1 get open command, so after 1 second then the open feedback for the generator 1 will be open, and the feedback of the open feedback of the generator 1 will be closed and received by the PLC, and then the closed feedback will be open and not been received by the PLC. So then I also create for the CB1. So CB1, let's say been open. Where is CB1? So we go here. Okay, CB1 basically this one, that one is CB1. So let's say we take CB6. So CB6 should be, we need to refer to the Excel. So CB6 is a VCU 116. So VCU 116 should be around here. VCU 116 CB6. So here, this one. Alright. So what happen if I press open command? So then close feedback will be open. Then the kilowatt will be simulated to 0. What happen if close? Then the kilowatt will be simulated to the maximum one. Alright, so here okay, I turn on all the generator. So what happen when I turn on all the generator? It will go to the bus bar B logic. Alright, since all you need online is 5, so this whole routine will take part. Alright, so in this simulation, I'll also add a few test runs so to check which run that get involved. Alright, so what I see that if we run all the 5 generator, the next load sheet is not come from the priority index B, but it come from the priority index A. So maybe, yeah, why currently not happen, because all the frequency is okay. Okay, let's talk about the frequency sheet. Alright, so from here we could understand that the spin reserve bus B need to over 1800, so it won't get shake. So here this one is 2000, that's why I put 2100, so it won't go to shake. Same goes to this one. Alright, so there is a two subroutine for frequency shift. So there is it 252. So this one for B and for A. Oh, like this one. So this one also 2000, and also 2000. So we can say that if all 5 generator run, so the what we call that one, the spin reserve need over than 2000. So let's see what happen if we run this one, CV6, we close the circuit breaker, and then the kilowatt go to the maximum one. Alright, so let's say now the spin reserve is 2100. Let's say I lower it down. Okay, so this one for the spin reserve B. So this one is A. So let's say I key in 1100. Right, so wait for 5 seconds. Or still 2000. Yes, so it go to shade. So I don't know, yeah, but basically our logic is to shade one by one, but in here I could see it shade all together. So let's see what happened in the logic. So this one go up, this one is not go up. Alright, so this one go up, then it trigger to here. So that one is a CB6 for the first one. That's why it here 1. Alright, so okay, again we simulate. So far, then we go. Yeah, I need to increase that one first. 1200 meter. I think I need more. Let's see. Cannot equal to, yes, now is 2100. Alright, before we proceed, from the logic I could observe there is a two kind of the circuit breaker. So the first one is VCV 101, and the another one is that from the generator. Okay, the reason why I say that one because okay, we need to cross reference until we could see the all unit that one. Yes, this one. So here, let's say we take for the unit number 1. Alright, this instruction means the generator number 1 is on load. Then this generator circuit breaker close. Alright, so what happened if I place this one? So VCB get open. Alright, so but here this one is not affected. So where is the logic for the VCB 101? So it's located at the let's see. Yes, this one. Alright. So generator CB1 open, and this one is a different kind of the tag. So this one, how could I say it relates to the generator, because this one come from the messaging. That means it come from the PLC that control the generator. But this one is come from the remote I/O for this PMS. So that means even the generator run, but if the VCB open, then yeah, I don't know. Let's see, it go to where? Yeah, it goes to, yeah, it gets alarm here. It get alarm. Okay. It also being indicated at the HMI. Alright. So okay. Now we test one more time. Since all this one is running. So let's say what happen if I lower down this one. 1900. Alright. Gets nothing from here. Alright, now I could see, okay, all 5 get shade. Yeah, so I could assume that testing setup is can be used to test out the modified logic. So yeah, feel free to contact me so I could set up this testing setup so you could control remotely. I hope we all can discuss if we have any kind of to discuss. Yes, please. See you again. Thank you very much for watching.